Let's discuss the problem number 8, which is basically a multidisciplinary problem. You can say it's from basically it's test 2 from thermodynamics and a bit of manufacturing engineering. So I would say manufacturing or production, you can say. It's basically a multi-discipline problem. Okay, so what is given is a wire is given and it's plastically deformed by means of some dye or something that is not known, okay, by application of force. Okay, and what is asked is during this process, so this force value is given 40 Newton and it drags it over a distance of 0.8 meters, and this is basically the displacement along the force direction. Okay, and the wire mass is given, which is 0.2 kg. The specific heat is given, which is 0.5 kilojoules per kg degree centigrade. And what is asked is the maximum increase of the average temperature of the wire. This is what is asked. Okay, so the work done by this force is basically F into D, and remember that in the problem it is given that D is the displacement along the force, so we can directly multiply it, otherwise we need to take the cos between force and the displacement. So force value is 40 Newton, this is 8, so the work done is 32 joules. Now assuming that this entire work done goes into plastically deforming the body, so that so if the entire work goes, so there is no velocity of this, the velocity of this wire is negligible, you can assume, so it doesn't have any kinetic energy, so the entire work done goes into plastic deformation. And we know that most of the plastic deformation the energy that goes into the deforming the wire, the plastic deformation, most of it goes into heat. And assuming that if the system is adiabatic, then this entire heat will increase the internal energy. So if there are no losses, so the total work done will be equal to the increase in internal energy. So that's why there are no losses, so the entire work done will go into the internal energy, and the internal energy is nothing but mass into specific heat into the temperature rise. That's why it is called maximum temperature rise, because the entire work done is going into the internal energy without any losses, no adiabatic losses, no change in the kinetic energy, nothing of that sort. So work done is 32, we have found out mass is given, specific heat is 0.5 kilojoules, so let's put kilojoules and delta T max. So the delta T max comes around 0.32 degrees centigrade, which is nothing but 0.3 roughly, and so the option is D. Thanks.